Howdy. Today I just wanted to go through a couple of questions dealing with transformations and talk about how to do it correctly. I didn't want people to get in the habit of just copying down the correct transformation, because obviously that doesn't do you any good. So let's go through and let's see if we can kind of just talk through it and make sure that we do each of them correctly. Now on this particular assignment, you're also going to be identifying specific points. All right? So let's go ahead and consider that. So we're going to determine the parent function. We're going to graph the parent function. We're going to describe the transformation separately. We're going to graph the non-parent function because of the transformations. And then we're going to identify the important points on the parent function and then also on the transformed function after talking about the changes. So let's look at our first equation here, number 1, which is 2x minus 3. All right, now the parent, of course, is linear. I guess that's where I would write linear. All right, now I'm going to go ahead and graph the parent function, which would be right here. Now, I've said in class that you need to do at least 5 points. If it takes you almost as much time to put more points down, go ahead and put more points, because it's going to make sure that your graph is a little bit nicer, a little bit better. So there we've got my original parent function. So now I'm going to switch to a different color. I'm going to talk about the transformations. Now, the original linear function is y equals x. So anything other than that is considered extra. That's what's going to cause the changes, the transformations. So I've got a 2 right here, and then I've got a negative 3 minus 3 right there. Now, it's important that we recognize that the 2 is being multiplied and that the 3 is being subtracted. All right, now, according to PEMDAS, the multiplication should come before the subtraction. So let's talk about the 2 first. Now, that 2 is being multiplied directly by the x. Rule number 1 in our class is that if it's being multiplied directly by the x, it will cause a horizontal change. So I'm going to write down right now, I know it's horizontal. So that means either it's going to be stretched side to side or it's going to be shifted side to side. Okay, now rule number 2 is if it's done directly to the x, which this is, it's 2 times x, then it should be the opposite. So instead of 2 times x, it's going to be x divided by 2. All right, or you could think of divided by 2 as being multiplied by 1/2. So anytime you multiply something by 1/2, that means it's going to be getting smaller, right? It's going to be half as big as it was before. And so what we're going to do is we're just going to go ahead and we're going to say, okay, horizontal, squish, you can use compression, of 1/2. All right, so now that's the first one. Let's go ahead and talk about the minus 3 now. So the minus 3 is going to, let's consider first, is it being applied directly to x? Well, no, it's outside of the 2x, right? The 2x is happening first. The minus 3 is just kind of an added thing on the outside of the parent function. And so I'm going to say that is not being applied directly to x, therefore it is not horizontal. It is vertical. And now that I know it's vertical, I can consider, well, rule number 2 says if it's done directly to x, it's the opposite. Well, this is not done directly to x, therefore it is not the opposite. Therefore, since it looks like it's subtracting 3, that's what we expect. So it should move down because it's vertical 3 spaces. All right, so now we want to actually do that to our graph. So what we're going to do is we're going to take each of our points and we're going to squish it by 1/2 and then move it down 3. Now there's a couple of ways that you can do this. Some people like to go, this is what I do, I go ahead and I do that first transformation all first. And so I'll take my x value, because this is horizontal, so I'll take the x value and I'll half it, right? OneNote doesn't like it. Okay, there we go. I'll take that x value of 2 and I'll half it. Take this x value of 3 and half it, right? And so I'll do that for each of my x values. Same thing down here. Each of those x values is going to be halved. Now you can see that squishing the graph. Now, those are not the actual points on the answer, right? Because I've only squished it. So now I need to move it down 3. You'll notice I didn't draw the solid line on here yet because that's not really my answer. Those are just kind of intermediate points. So now I need to move them down 3. So I'll take each of those points and I'll go 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Yes, I can count to 3. Yay, Mr. Bywater. 1, 2, 3, and so on and so forth until you have all the points on your line, and then you can draw this. Alright, I guess I should have used a ruler, but I didn't. You should. Anyway, there we go. So there's our final graph. Alright, you can tell that it's a little bit steeper, right? And then it's also been shifted down. All right. Now, one thing that I do want to point out is that you could have also done this point by point. So you can take a point. So, for example, this 4, 4. You can half it and then shift it down 3. Done. And then you can pick the next point right here at 2, 2. And you can half it, the x value, and then shift it down 3. 1, 2, 3. So instead of doing one line at a time, you can do everything for one point at a time. Just make sure that you follow PEMDAS, follow the rules. You know, this point is 0, 0, multiplied by 1/2 would still be 0, 0, move it down 3. Right? So you can do that as well. All right, so let's go ahead and look at the points now. Okay, so the first point that we're looking at is the x-intercept. So for the parent function, the x-intercept is 0, 0. Now, when it changes, you're going to squish horizontally. Now, squish horizontal is not going to change the x-intercept because the x-intercept being at 0, when you multiply it by 1/2, it's still going to be 0. But then you're going to shift it down. And so when you shift it down, that's going to affect the position of your x-intercept. So the new x-intercept we can see right here is going to be at 1.5, 0. All right. Let's look at the y-intercept. The y-intercept originally was, of course, at 0, 0 because that's where I was crossing the y-axis. You can see now that it has been shifted down 3 spaces to 0, -3. Again, the horizontal did not affect the y-intercept, all right, because it's right on the y-axis. Okay, the vertex, there was none because it is linear. Okay, the asymptote, again, there is none since it is linear. Okay, now the domain are the x values. So if we look at our parent function, we note that it goes to the right, it goes forever and ever to the right, and it goes forever and ever to the left. Since there's nowhere where x doesn't exist, then we can just say x is of the set of real numbers. Now that will also be the case for our new function. All right, now if we go to the range, if I start at the middle and say, okay, can I go up? Yes, I can go up. Does it keep going up? Yes, it does. So it goes up and up forever. Down? Yes, it also goes down and down forever. And so I can then go ahead and say that y is also of the set of real numbers. Okay, so I hope it helped you to kind of talk through it and look at that. There's no change to the domain and range, so everything will be exactly the same. I'm going to go ahead and stop this one, and then if you would like to see another one, then go ahead and just watch the other video.